Assalamualaikum warahmatullahi wabarakatuh and a good day. In this video, I will share with you Chapter 4 on test of hypothesis, which will focus on the ratio of population variances sigma 1 squared to sigma 2 squared, or on a ratio of two population standard deviations sigma 1 to sigma 2. Let's first look at this topic's learning objectives in the subsequent slide. These topics' learning objectives are similar to learning objectives on other topics in this Chapter 4. The difference is on the parameter that we want to test this time, which is the ratio of population variances or standard deviations. Therefore, at the end of learning this topic, you should be able to achieve these 5 learning objectives. First, you should be able to perform a statistical hypothesis test on the ratios of sigma 1 squared to sigma 2 squared or sigma 1 to sigma 2. Second, you should be able to determine the only one case on testing the ratios of variability measures. Remember, both variance and standard deviation measure variability. Third, you should be able to calculate the suitable test statistic in testing these ratios. Fourth, you should be able to make a correct statistical decision and draw a practical conclusion on these ratios. And finally, you should be able to compare the variability measures either between the population variances or between the population standard deviations meaningfully. We look first at the statistical hypothesis tests on the ratio of population variances before looking into testing the ratio of population standard deviations. Similar to testing other parameters, here we also have 3 types of hypothesis tests as listed in this table. The first type is the two-sided test denoted by an equal sign under H1, when we want to test if the first population variance is different from the second population variance, or if the ratio between the two variances is different from one under the alternative hypothesis H1. Next, the second type of hypothesis test is the left-sided test, denoted by a less than sign under H1, when we want to test if sigma 1 squared is less than sigma 2 squared, or if the ratio of sigma 1 squared to sigma 2 squared is less than 1 under H1. And finally, we have a right-sided alternative hypothesis test denoted by a more than sign under H1 when we want to test if sigma 1 squared is more than sigma 2 squared, or if the ratio of these two population variances is greater than 1 under the alternative hypothesis H1. Similar to what we did in constructing a confidence interval for the ratios in Chapter 3, again we will use an F distribution as the underlying sampling distribution assumed in this topic. Therefore, we will have an F-test statistic to be the only choice of test statistic in this topic. So the test criterion or the rejection rule for the two-sided test is reject H0 if F-test is less than the left-sided critical value, which is F1 minus alpha over 2 nu1 nu2, or if F-test is greater than the right-sided critical value, that is F alpha over 2 nu1 nu2. For a left-sided test, we will reject H0 if F-test is less than the left-sided critical value, which is F1 minus alpha nu1 nu2. And finally, for a right-sided test, we will reject H0 if F-test is greater than F alpha nu1 nu2. What is the definition of F-test statistic? It is simply the ratio of two sample variances S1 squared to S2 squared. 3 points to note. First, the critical values can never be negative, even for the left-sided critical values, since F values are always non-negative. Second, the degrees of freedom nu1 is n1 minus 1 and nu2 is n2 minus 1. And the final note, F critical values on the left are not directly available in the statistical table. Therefore, please use this theory F1 minus alpha nu1 nu2 is equal to 1 over F alpha nu2 nu1. Exactly the same testing procedure should be used when testing the ratio of two population standard deviations. That is, we still use the same test criterion or decision rule and the same test statistic as well as the same critical values. Please do not ever square root the test statistic and critical values when you test sigma 1 against sigma 2. Let us now look at an example on task 4.14 in Statistics for Engineers textbook, page 106. The following data represent the times taken by two machines in producing an electrical part where the times are in milliseconds. Assuming that the distributions of the times are approximately normal, can we conclude that there is a significant difference in the variability of the times in producing an electrical part by machines 1 and 2 at alpha equal to 0.05? Here we are to test if there is any significant difference in the variability of the times, that is, to test if sigma 1 squared is significantly different from sigma 2 squared. So we need to know the sample variances or sample standard deviations from the sample data. From machine 1, we can directly see that N1 is 5, and from a scientific calculator, we can calculate S1 equal to 8.8769. Whereas from machine 2, we have N2 equal to 7 and S2 can be found to be 30.2214. Based on this information, we can then proceed with performing a statistical test on whether the variances are the same or different at the level of significance alpha equal to 0.05. Continue with solving task 4.14 since we are to test if there is any significant difference in the variability of the times in producing an electrical part by machine 1 and machine 2. Then we are actually to test if there is any difference in the population variances since the variances measure variability. Therefore, the null hypothesis H0 is sigma 1 squared is equal to sigma 2 squared, or the ratio of two population variances is 1, whereas the alternative hypothesis H1 is sigma 1 squared is different from sigma 2 squared, that is, the ratio of the two population variances is different from 1. Since we have a two-sided alternative hypothesis test, then the rejection rule is reject H0 if F test is less than the left-sided critical value, which is F1 minus alpha over 2, 46. Since alpha is 5% or 0.05, 1 minus alpha over 2 is simply 0.975. Then the left-sided critical value is F0.97546. However, this critical value is not available directly in the statistical table booklet. What we need to do first is to calculate its value by taking 1 over F0.02564. That is 1 over 9.20, which is equal to 0.1087. This technique has already been explained step by step in Chapter 3. The rejection rule is not yet complete though. We would also reject H0 if the f-test is greater than the right-sided critical value, which is f0.02546, given by 6.23. Now we need to calculate the f-test value, which is the ratio of two sample variances S1 squared to S2 squared. You may want to check if the value of f-test is 0.0863, and if you notice, this value actually falls in the left-sided critical region since it is less than the left-sided critical value. Hence, our decision is to reject the null hypothesis H0. What can we conclude here? What is the conclusion? Yes, we can conclude that there is a significant difference in the variability of the times in producing an electrical part by machines 1 and 2 at the level of significance alpha equal to 0.05. For the second example in this video, please refer to exercise 4 question 13 again on page 108 from the Statistics for Engineers textbook. Based on this question, we have identified or recognized the information given in the question when we did a statistical test on the difference between two population means. Our focus this time, however, is to determine whether the two types of soil experience a difference in the variability of gamma radiation dose at alpha equal to 0.02 or 2%. Please change the alpha value for testing the variability in your textbook from 0.01 to 0.02. So based on this question, we want to test if sigma 1 squared is different from sigma 2 squared, or if the ratio of the two population variances is different from 1. Therefore, the parameter of interest to be tested here is the ratio of sigma 1 squared to sigma 2 squared. As such, only one case we should use which involves an f-test statistic. Therefore, we can perform a two-sided test on the ratio of population variances for solving this question at the level of significance alpha equal to 0.02. Proceed with solving question 13 in this slide. Since we want to determine if the two types of soil experience a difference in the variability of gamma radiation dose, we can write under the null hypothesis H0 sigma 1 squared is equal to sigma 2 squared, implying that the ratio of the two population variances is equal to 1. Whereas under H1, we can write sigma 1 squared is not the same or different from sigma 2 squared, which implies that the ratio of the two population variances is different from 1. Obviously, we have a two-sided alternative hypothesis test. Please note that if you want to test the ratio of standard deviations instead of the ratio of population variances, this is also acceptable since the standard deviations also measure variability. Now, what next? We know that we are to run the test at alpha equal to 0.02, and at the same time we have a two-sided test. Then we should have two critical values at alpha over 2, which is 0.01 at both sides left and right of the underlying sampling distribution, which is an F distribution in this question. Therefore, the rejection rule is to reject H0 if f-test is less than the left-sided critical value, which is 0.0878, or if f-test is greater than the right-sided critical value, given by 15.52. Please figure out on your own how to get these two critical values. After setting up the rejection rule, now we need to calculate the f-test statistic, which is the ratio of two sample variances S1 squared to S2 squared given by 0.5625. Remember, if you test sigma 1 against sigma 2, you still use exactly the very same f-test statistic. In short, please do not square root this f-test statistic value if you test the ratio of standard deviations. Back to the f-test statistic value, you can clearly see that the f-test value is in the acceptance region as it is in between the critical values. That is, the f-test value is in between 0.0878 and 15.52. Therefore, we fail to reject H0 or we do not reject H0. What can we conclude? We may say that there is no evidence from the sample information or sample data that the population variances are different. Therefore, we can conclude further that the two types of soil do not experience a significant difference in the variability of gamma radiation dose at the level of significance alpha equal to 0.02 or 2%. We are at the end of this session. Let us check on the learning objectives of this topic. Hopefully, after learning this topic with a number of good efforts and practices, you may question yourselves whether or not you are able to achieve the following learning objectives. First, are you able to perform a hypothesis test on the ratio of population variances or standard deviations? Again, you only test a population parameter, and in this topic, the population parameter is the ratio of population variances or the ratio of population standard deviations. Please bear in mind that you do not test a ratio of sample variances. Second, are you able to determine the only case on testing these ratios? We only have one case here that relates to the third objective, which is to calculate the chosen test statistic, which is an f-test, correctly. Next, are you now able to make a statistical decision correctly and write a sound and practical conclusion? And finally, you should check that are you able to compare the two population variances, which are the measures of variability, meaningfully? Of course, by just listening to this video is not enough. You need to practice and make a great deal of effort to solve more questions in order to gain more understanding, not only on this topic, but also on other topics that we have looked through before. If you have any question related to this topic in particular or related to the course in general, please do not hesitate to WhatsApp me personally. Until then, Assalamualaikum warahmatullahi wabarakatuh, and thank you for watching.